How does specific heat change with temperature and substances? Imagine heating a pot of water or a metal rod and wondering how much energy it takes to warm them up. That's where specific heat comes into play. It tells us how much heat energy is needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Think of it as the substance's own energy storage capacity. Now, this property depends on the material's molecular structure and how its atoms or molecules are bonded together. For many solids and liquids, the specific heat stays pretty steady over moderate temperature ranges. But as temperatures climb higher, things get more interesting. In solids, at very low temperatures, specific heat tends to increase as temperature rises. This is because molecules don't move much at low temperatures, but as they gain energy, their motion ramps up. Models like Einstein and Debye explain this behavior by considering quantum mechanics, which describes how atoms vibrate at different energies. Once the temperature reaches room temperature or higher, the specific heat usually levels off and stays nearly constant. This is explained by the Dulong-Petty law, which states that atoms in a solid vibrate in a way that results in a stable energy capacity. Gases behave a bit differently. Their specific heat varies more noticeably with temperature. This is because gases have more freedom of movement, and how they absorb energy depends on whether they are heated at constant volume or constant pressure. When heated at constant volume, the internal energy increases, but no work is done on the surroundings. When heated at constant pressure, some energy goes into expanding the gas, so the specific heat is higher. As temperature increases, the difference between these two specific heats becomes more apparent. Phase changes like melting or boiling are special cases. During these transitions, the temperature stays the same even as heat is added. The energy goes into changing the substance's phase, not increasing its temperature. So, during melting or boiling, the concept of specific heat doesn't really apply because the temperature remains constant despite heat input. Knowing how specific heat changes with temperature helps in many practical areas. Engineers use it to design systems for heating and cooling. For example, water's high and relatively stable specific heat makes it ideal for temperature regulation in both natural environments and industrial processes. Materials with different specific heats respond differently to heat, so choosing the right one depends on what you need to achieve. In summary, specific heat generally increases at low temperatures, especially in solids, and then tends to stabilize at higher temperatures. In gases, it varies more with temperature and depends on how the substance is heated. Understanding these changes helps us better control and predict how materials respond to heat in everyday life and technology.